We continue our unit on ecology by looking at population ecology. A population is a group of individuals of the same species that live in the same area at the same time, and there's several important characteristics that define a population. One is their geographic distribution, how far are they spread out? Their density, which is just the number of organisms in a specific area. Their dispersion, how far they go beyond that area. Growth rate, how quickly are they growing, and their age structure, which is the average age of the individuals in that population. Populations tend to grow at various rates, but for the most part they stay stable over time. Although there are fluctuations, at times they may go through tremendous growth or even rapid decline. Under normal circumstances, there tend to be three factors that either greatly increase or decrease the size of the population. The first are the number of births within the population, then the number of deaths, and then the number of individuals in that population that either enter or leave the population. And we have a couple terms that you need to know. The one is for the number of births, we call that natality, which is an ecological term for births. And the number of deaths we call mortality, which is the number of deaths of the individuals in that population. There are two processes that increase the size of the population. The first is the birth rate, which I mentioned earlier is the natality of the population. The second is immigration. Immigration starts with I, and so that helps me remember that immigration are species in that population that move in to the area. There are two processes that decrease the size of the population. The first is death rate, which again is the mortality rate, and emigration. And emigration begins with the letter E, and so I remember what emigration means. It means that they actually exit the population or move to a different area. So under what conditions or circumstances would rapid growth occur in a population? Of course, they'd need to have plenty of space, an abundance of food, no predators or disease. And so if all of these factors for reproduction and growth are ideal, the population might grow exponentially. Eventually, a population will reach what we're going to call the carrying capacity of the environment. The carrying capacity is the number of individuals the environment can support over a long period of time. In a sense, the carrying capacity is like the glass ceiling or the cap, so to speak, of how much that environment can actually support, the number of individuals that environment can support based on its size, its resource availability, and other variables like that. The exponential growth model of a population is often called a J-curve, and you can see because it looks like the letter J, but rarely does any population ever fulfill that, simply because they overshoot the carrying capacity of the environment. And so even though a population might grow exponentially for a period of time, it hits the point in the environment where it hits the carrying capacity, where the environment can no longer sustain that number of individuals. In other words, when they hit that carrying capacity where there are limitations of food supply, perhaps there's an abundance of predators, perhaps disease or other things come into play, members of that population will either die or starve to death, which causes the population to drop below the carrying capacity. And so in reality, what happens is the population or the number of individuals of that species grow to a certain point, hit the carrying capacity, and then they tend to fluctuate above and below that line as the population faces limitations on the resources that they need to survive. So how will resources be limited during the growth of the population? What resources are we talking about? Well, first and foremost, as more and more individuals enter that population, food can become more and more scarce. A lack of food causes competition among that species because they all want food to eat and to survive. There may be a shortage of water. As more individuals fill that area, it may cause disease to be introduced into the population, which would certainly cause individuals to become ill or die. Eventually, the population will run out of space, and some will have to move and some will die. And another factor is that additional predators may be attracted to that area because of the rising number of prey, and those predators will kill them off, causing that population to decrease. The earlier model of population growth that we talked about was exponential growth, and that is, as the population increases, more and more individuals are born, there's unlimited food supply and a lack of predators, we would see the population to continue to grow at an exponential rate. But in reality, that doesn't happen because they hit this line, this ceiling, this wall, so to speak, which is the carrying capacity. And so when birth rate equals the death rate, the growth of the population reaches zero. It tends to stop. And so as the population reaches this carrying capacity, it tends to slow down. And like I said earlier, it tends to fluctuate above and below the line of the carrying capacity. All of this points us to the fact that there are limits to how big and how fast a population can grow. And in ecology, we call this concept limiting factors. No population can undergo exponential growth forever. There are simply limits to how fast and how big a population can grow. A limiting factor is just any factor that causes a population growth to decrease. And some of these limiting factors are competition, predation, parasitism, disease, drought and other climatic extremes, and of course human disturbances, the things that we introduce into that population. There are two basic types of limiting factors. Again, a limiting factor is what causes a population to stop its growth in the environment that it's living in. The first is a density-dependent factor, and this simply means that the limiting factor only becomes limiting when the population density reaches a certain level. In other words, it simply gets too big and it can no longer be sustained in the environment that it lives in. Specifically, some of the density-dependent limiting factors would be competition among species in that population, predation, individuals that come in, organisms that feed on that species, parasitism and disease, parasites that come in and cause that population to die off, shortages of food, and shortages of places where those individuals can live, their nesting sites. The second and last type of limiting factor are what we call density independent factors, and this simply means that the limiting factor happens from outside the actual population that's being affected. Examples of this include unusual weather, natural disasters such as floods and fires. It includes human activities such as the damming of a river and the clear cutting of a forest. And a great example of this would be the fires in northern Minnesota that burned down a lot of the forests in that area. And it was a limiting factor because it took away a lot of the places where organisms would have lived, used as resources for food, hid from predators. And so it impacted the populations of wolves, of deer, and moose. Hope this helps. Good luck on this unit, and I'll talk to you in the next video.